Before I start, I'll just say a little, just a brief one about myself. As I've said, my name is Yemi Ayola. I currently work with an insurance organization. My background has been testing all through. My mentor is the one that just talked now, Mr. Deji. He's been the one that I've been putting me through, and I've been working for over a decade now in testing. So that's predominantly me working in an insurance organization as a senior test lead, and it's been a fantastic journey all through. If you're in this class with us today, I'll say um, you have chosen the right path. And I'm so certain that just with little effort, we'll all be working together very soon in all the field of your choice. I welcome you all on board, and I'll be driving through manual testing. So the rule of this game, the way we are going to do it today, is that if you've got any question, please always just pop it in the chat, just for me to know that yes, I'll be viewing the chat regularly, maybe every 30 minutes, just to look at your questions. And I've also got my colleagues on ground, which will be answering the questions. And anything that you've got regarding manual testing, regarding whatever we are doing today, I'm here to answer all the questions. This is a course and a class that I'm so certain that if you put your little best and your time in, I will tell you that you are going to achieve the goal. A lot of testimonies, and it's fully handsome. Compare it with anywhere you're coming from. I can tell you that you have made the right choice. So, good evening all. As I've said, I'll start sharing my screen. And this is manual testing class. Yeah. So this is introduction to manual to software testing, which is the manual bit of it. I know you've gone through some of the Java classes, but predominantly, this is the foundation of testing. This is the foundation of where you are going to start when it comes to testing. Before you can say you are going to do automation, you have to have a brief understanding and knowledge about what testing is and what are the nitty-gritties, what are the types of testing, what are the ways, what are the processes, the procedure to carry out testing. This is the foundation. So you need to first lay the foundation, then we'll move further, and you've already had your sessions regarding Java automation using Java. So yeah, so this is introduction to software testing, and as I've said, any question, please just let me know. So the first thing I'm going to talk about is the background. How do we start? What are the things? You'll be hearing manual testing, listening to everybody talking about manual testing, talking about testing generally. You'll ask that, what are we talking? What are we saying about when it comes to testing? Now, I'll say testing is in different form. Testing is part of us. Testing is a phase of life. Everything you do is one form of testing or the other. Take an example. If you want to know if you want to get warm water, you don't want to be too hot, you don't want to be too cold. You can't just get to the tap and open the hot water tap. It will always be hot water. If you open the cold water tap, it's going to be cold. So before you want to do that, you want to test, okay, now I need warm water. Takes more of little, take more of warm. You pour some on your hand. Oh yeah, this is the temperature I actually need. What you're exactly doing is that you are testing. Take another form. Maybe you want to taste a particular food. How will you say? You can't just say judge by the look of the food that you have seen. Oh, this is a palatable food. It looks so good. That is the look. But you really want to know the taste. The taste is now when you put it in your mouth to test it. What you're doing is testing. Take another example. You want to write with a pen. Everybody is always conscious. You want to sign a document. The first thing is that you want to first test that pen on a particular piece of paper to check if that pen is working properly before you attest or sign whatever document or whatever you want to use the pen for. What you've exactly done is that you have tested. Now tell me, what exactly don't we test? We test practically everything. So hence, if you are testing, or we are going to, you have to, the major thing you are trying to do is to check whatever you want to use, if it's working as expected, if it's the exact thing that you need. There are several examples I can give you regarding testing. If you wake up in the morning, before you come down from your bed, you will still stretch. You are also testing. If you look, there are things that I can't mention that we will say, a lot of things that we test about. But this background is just an example of a car. So now, if you want to buy a car, I just go to the delivery shop or or I want to use a particular brand of car. The first thing is that you go to the showroom, you want to get there, you want to test drive the car. So all this form is testing. Now, when you get there, you don't want to get there to see one part of the wheel off. When it's meant to be a 5-wheel, you're seeing a 3-wheel. Of course, you're going to question that. Why is this? When you're meant to have a 5-door or maybe a 4-door, you've got 3 doors. So those are the questions you're going to look into. But before you get to the showroom, you would have gotten a manual, a guide. That manual will tell you everything in the vehicle you're going to purchase. Hence, when you get there, you actually know that this is what I'm going to see there. I just want to test it. You don't want to start the car and just find out that the engine is not sounding as expected, or there's no engine there. That will raise an alarm. It will raise a question. You won't even put your money on such a car. Give also an example. Maybe you're trying to shop online. You've added everything into your shopping cart and you are now ready to pay. You find out that as you're ready to pay, you have seen another person's shopping cart, everything he or she has done online, and the person's card details is showing there. You are not going to put your card there. So you won't be able to use that online application, because you will just look, oh, for this particular customer to have his own account details online, then there must be an issue. Then you'll be able to. What causes that is when proper testing is not done. So that's why I said every phase that we do is proper testing. I mean, we have to test, be it food, be it life, be it anything. As we go into this, you'll see the reason why we actually need to continue to test properly. That phase is coming soon. So more examples are in the textbooks. We've got the soft copy of the textbook. You can actually ask for that. Then the next thing is, what are the topics do we intend to cover in this session of manual testing? These are the topics that we are going to cover, and this has to do with fundamentals of testing, testing principle, test processes. We are talking about code of ethics. So that's how the proper procedures are, what are our expectations. Testing life cycle, of course, as I've said, there's a process, there's a procedure. This is the foundation we're actually going through. When I talk about testing life cycle, every phase of life has got a life cycle. I started when I was in the womb. I was 1 year, I'm 5 years, I'm 10 years, and that's the way we are growing. That is a phase, that is a life cycle. So we also have testing life cycle. We are starting here, it's going to move to the next stage, it's going to move that's the life cycle. Also, we have test levels. What are our different test levels? We've got test types, we've got static testing, we've got dynamic testing, we've got test case design, the test case design technique, and the test management. Practically, these ones are the major thing you have come to do in testing. This phase are the things that you're expected to know before you want to test. Let me give you an example again. If I take an example of a doctor. If he or she doesn't know how to do his procedure, he can't, you can't be certified as a doctor. If you as a tester don't have the visibility or understanding of this, you can't also be satisfied as a tester. So these are the way things are structured when it comes to testing. As I've said, any question at any time, please pop it up in the chat. Then the next phase we are going to look at, we are doing software testing. What's name? What are the disciplines? What are the roles that is attached to software testers? You're a QA, you can be a QA as a QA engineer, that's a quality assurance engineer. You can be a manual tester, you can be a UAT tester, you can be a test analyst, you can be a web analyst, you can be a performance tester, you can be security, you can be automation tester. You now currently, as you are embarking on this journey of software testing, of automation testing, then you've got wider range. You are an engineer, you're an automation tester, you're a manual tester, you're a functional tester, be it anything regarding testing, you are there. You're a performance tester, talk about pen tester. So it's all has to do with different roles, different names. The same thing this guy is going to do here when that role comes out is what this other guy is going to do as an agile tester. So it's just this different roles, but we are all coming together. That's why I said this foundation, this whole thing, this process, that is what makes you a tester. Everything here is what satisfies you as a tester. So if you can do it, then you can participate. You are one of these people here. In maybe you get a particular role, you can be this person in that role. Now you leave that organization, you can come back and be this person, software tester. If you leave that place, you can say, oh, automation tester, all these things are just names. But the main thing you are going to do is to know your foundation, know the nitty-gritty, have a good understanding of what you're doing. So practically, this is just the structure and the skills of the way testing phases are, how is where structured, what is the main skills that is needed to get it. If you can see this guy in front, the testing he's got everything. So if you want to call yourself a software engineer, you must understand testing in full capacity. If you want to call yourself a test analyst, you must understand testing in full capacity. If you want to call yourself an automation tester, you must understand testing full. So that's the reason that testing has the larger, so if you look at it, it's got the larger one in these skill sets. We've got software tester, we've got system test analyst. So all these people still comprises of that, the skills that we have got. So it's just an interesting thing just to wave and just see it. This is just still a graph of 2001, last year. Practically, this year is way back. You would even get more than this. I'm so certain about that. It depends on how you can market yourself. It depends on the effort you put into what you're doing. As I've said, I could hear some lady, someone asking question previously today. I'm also a mom of 3. Nothing stops you from moving or doing your work. No, we all started that way. So nothing is a barrier. You can, if you put just your little effort in this course, I'm telling you, you won't regret it. You would come and actually testify. The major full hands-on, I'll tell you the truth, is when we are doing the internship. You get the help of everyone. You've got fantastic people in the team, well knowledgeable in the team that are ready for you. So hopefully we all see ourselves at the class. These are the salary expectation. I'm not expecting anyone that is working that passed through this training from the beginning to the end, a dedicated person. You can't go for a minimum of 45. No, that's the way you are going to, that's where you might think that's the minimum you can go for as long as you have gone through the rigorous training, dedicated your time. I'm telling you, that's the type of salary you're going to, that's if you will. You're still going to get 60, 70. There are even six figures in testing. You are going to rock the boat soon, and we'll see. Yeah. So that takes us to another phase of it. Everything I've said initially is just to welcome you. I've said it, I told you, I've given you the background, the interesting and juicy things about testing. That now we want to dive into it. We want to get a good understanding of what testing is. Testing as a discipline. When I mean discipline, when you want to categorize yourself that who is actually a good software tester. Now, you might be a tester, I might be a tester, we might bring 10 people into the room that are testers. But what makes you different is when you know the real process of testing, what it entails, what is embedded, what is expected of you in the testing. Let's go through it one after the other, and you'll see how it is. So I said a good software tester. What takes you a good software tester? You must have good verbal and written communication, coincide simple and firm. When I mean verbal and written communication, I have seen this error, XYZ. Take a screenshot of it, put it there, a screenshot, including the URL and everything. Take that screenshot, put it there. I've seen this error, and just do a step to reproduce the error. Simple, send it to it. Nobody can ask you. If you snap a picture of yourself, if you look at print out the picture, it's whatever you see in the picture that is you. You can't snap a dark person and you expect the picture to bring someone that is white. No, it's not possible. So it's whatever you are. It's just whatever you saw is whatever you put in there. When you put the screenshot and you send it to the person, no one is going to come back to you because the picture says it all. Just something for people to understand. That's why I said good verbal and written communication. In your verbal, what has happened? XYZ, I've gone to this domain. I've tried to access this domain. That's your URL. And once I click on it, I'm getting this, cannot refresh page, these sites cannot be accessed, blah, blah. So you can just, whatever error you're getting, just state it to it. The devs actually know exactly where to go and fix it. Whoever has developed the application. Also, good software tester, you must have the passion. If you don't like what you're doing, if you don't have the passion for what you're doing, then there's no need for you to continue in that thing. So you must have the passion. Must have the technical and analytic skills. What do we mean by that? You are now talking about automation. You are talking about Java. That is the trend. That's your technical skills. You've got the attitude towards it, your attitude, your productivity. These are the things that are needed for you to be a good software tester. Now, what are the objectives? In this phase, what I'm thinking, what we want to go through, what are the objectives? You'll be asking questions. Oh, she's been saying everything about testing. Tell me what exactly is the meaning of testing? So my objectives in this Next phase is to look at what is testing, how is testing done, why is testing necessary, the general principles of testing, fundamentals of testing. Then I've just got a self-assessment question. I'll just be asking you some questions and you can. So this is just to beautify it for you to get a good face of it. Of course, with the sunshine today in UK and everything, the heat wave and all, I just thought let's give ourselves a beautiful cooling of the day. So that's still another phase. What is testing? Same thing from the previous slide. Now, testing. I've used this background just for us to know there are different phases of testing. Testing. Oh, yeah, me, you've just been talking about testing. What exactly is testing? This is an activity that is performed to demonstrate that something is working as expected. That is it. Something is working as expected. Now, with an example of you trying to check a pen on a piece of paper gives you to check that, is this pen working as expected? That is an example before you start using it. Is that water warm before I drink it? That is an expectation that this thing is working as expected. But there are things that follows for it to work as expected. There are expectations. Now you'll be saying, oh, Yemi, you're just giving us real life things have been going. Dave, put us through and let's understand it on the field. Now, when I mean something is working as expected, take for instance, you've got to Google, just go to Google and just type in any word, maybe testing. We've got certain people in the team that have got different work to do before we can start testing. You are part of that sprint group. You are part of that group to make whatever application you are working with. Now, let me give you an example. Is that we want to build like a software, an application. In your team, our expectation is that we are going to get a project manager who is going to drive us through, is going to be the person that is going to manage the whole project. In some places, you have a scrum master to assist the project manager. Then you have a business analyst. You've got the developers. You've got solution architects. You've got data analysts. You've got testers, test analysts, which is you and I, that we are going to test that application. So now that's the business analyst gets us the mind of the person that wants to build the application. When I mean the mind, it tells us this is what is expected. This is what you want in this application. This is the things we need in this application. Then once we have the blueprint that this is what is expected, we all have an understanding of it. Then we can start testing towards it. Then whatever we are testing, we'll be mapping our testing to ensure that is in accordance to what the business analysts have given to us. So if you are asked to test a login functionality, you will ensure that the login is working as expected. What are the things that are meant to work in for a login? We take a login scenario. Everyone knows how to log in. A username and password. You check the functionality of the username. That is it working as expected when you put your password. Those are the things that testing is. These are the things that are performed to demonstrate that things login functionality, search functionality, adding to cart functionality is working as expected. Now, you'll be asking, oh, is this testing really for me? Is testing for me? That's the question you would have been asking. All this that I'm saying, is it not difficult? Then let's find out. So the next procedure is testing as a discipline. So for you to say you are good, you understand it, you as a tester, you must be inquisitive, you must work smartly, you must think out of the box, you must be patient, you must pay attention to details. Most people, when you go to meeting, even when you are working from home, it's easier. I tell people, I try to scribble every word down because those things, when I go back to it, it reminds me of whatever we have discussed. Now you going into a meeting and feeling that your head is majorly a calculator or can reserve every word that someone has said. There's no how. You will miss out some things. But when you jot some things down, you'll be able to go back to it and be able to help yourself when doing your test preparation. Now, attention to details. These are commonly meant to be when you are given requirements, ask questions. If you don't understand, it's better they explain on and on for you to understand than for you to test wrongly and give the impression that the application or the software or the system is working as expected. Now, thinking out of the box. What is thinking out of the box? That phase is coming into when we start doing our test case design. You have to think out of the box. What happens if, for instance, I'm doing a login, you just want to do the happy part? No, every part, life is in two phases. Is it a good or bad? Positive or negative? So you can't always want the good parts without going back to fetch and look at the bad part. So in testing, we do both positive and negative. So when you see, oh, this part is sweet, the happy part is always a good part. Everybody wants it to work. They'll tell you it's working. But I can tell you, the negative testing is what breaks the system. And let me tell you, when a user starts using an application, negative testing is more than the positive scenario. Reason is that I'm learning an application for the first time. You have given me an application for me to use. I will start trying different things because I don't even know the application. So while trying it, things won't work. So if I put in invalid details, then what happens? Those things will break. Now, at that time that you are using the application, don't forget the stress volume testing, that's performance testing, is going on. Maybe 1 million people are actually using the same application. So everything will crash at the same time. But if proper testing has been done, if you have thought out of the box to look at, oh, if 50 people are using it, what happens? If 100 people are using it, what happens? 1 million. So these are the thoughts. And also, you need to be patient. If you're not patient, you can't do testing. I'm telling you, you can't do testing. Not in a place where you have data that you have to do some data checks, ensure data integrity, ensure regulatory rules are followed. You have to be patient. They are systematic. If you are rushing to, you want to jump the gun, you find out that when that goes into UAT, all your flaws will be shown. So you want to try so much that you capture all the bug while you are in a particular, maybe while you're in seat, while you're doing your system integration testing, you want to capture a lot of things before it gets to the users, before it gets to UAT. These are the things. Attention to details. You can even be going for an interview. The logic about it is that if you're going for a face-to-face interview, as you're coming in, try and notice just few things, catching phrases. Look at the environment while you're coming. What is in there? What is actually in front of their door? When you get to the reception, you will see some things, some banners. They might just write some catching words there, which just look at it. When you're getting to where you're going to do the interview, know each of the floors, know where you are actually going to, so that when you are taken inside the interview, you have said it, you have done your speech, and you say you pay attention to details. And I ask you a question: where exactly, what was in front of the door when you were coming in? And you are paying attention to details, and you can't tell me. You could just say, the person could just ask you that, what is the question, what is in front of the door? And you give an answer. You might just say, congratulations, you've gotten the job. You don't need to do further interview. That's the way it is. So it depends on whatever you say is what people hold you to. So you as a tester, you must have all these characteristics. You must have all this embedded when it comes to you doing testing. Who can test? Who can test? From everything I've said now, is it so? Everyone knows that you can take a pen. Even a baby will take a pen and scribble with it. You can take water and taste the water. You can do things. So anybody can test. Testing is not rocket science. So now, what can be tested? So in this phase, when I say what can be tested, what can be tested? There are two things that can be tested. We've got hardware and software. What is hardware? Hardware are physical devices, something you can touch and see. Take, for example, a laptop. A laptop is an example of what an hardware is. You can actually, but for a software, it's something that you cannot touch or see. For example, your internet, the games, you don't know what is inside the games. So these are the things that can be tested. So two things can be tested: hardware, software. Hardware, physical devices that you can see, e.g., laptop. Software, something you cannot see. Internet, games. Now, I look at this map and just say, oh, what are the reference point, touch point? So we use different ones. Guru 99 is a quick reference book that you can go through. Tutorial point. You can use Google. There are a lot of materials online that you can actually use you can use for testing, to learn more and to read. So there are different ones. You can look at W3 schools. You can look different things that you can use online. So software testing, as you have said, software testing is one of the disciplines, is one of the type of tests, the type of the name or role is one of the roles. And as you have been saying, software testing, this is an activity that is expected to demonstrate that a software, be it a system, be it a product, be it a mobile application, is working as expected. And that is just everything about testing, to ensure that a particular software, application, product, program is working as expected. Software testing is not complex. It is not difficult to implement, execute, or practice. Software testing is a discipline, is a role. So you might see a job application, a job role that will say, we need software tester. It's a role. How can software be tested? It can be tested in two ways, manually and automatically. Manually, you're in this class, we are going to do manual testing. Testers execute test cases without any tool. That is manual testing. You're going to do it manually. So which means your data entry, for example, to a particular application software, you're going to be entering the data manually without using any tool. But when you're talking about automation, you are going to be using tools. Hence, you're doing Java, you've installed different applications, different library software on your machine. This is to enhance you, to help you automate whatever application you want to automate. So testing can be done in two ways, manually, automatedly. There is no full 100% automation. You've still got to do some things manually. Some verification, validation testing are done manually. Why do we test? You'll be looking at it that, oh, I've been saying it, oh, testing and this. So currently, think, why do you think we need to test? Give it, for example, you've gone to the showroom, you want to buy, you've got there, you want to get a car. And they just tell you, this car is good, it's fantastic. Just, you didn't test it, you didn't do anything to it. And you get home, you try to start the car, it's not even starting. It doesn't have a brake, it doesn't have that. Then absolutely, there's a big consequences if you don't actually test properly, if you don't test it. The reason why we need to test is to avoid failure, avoid software failure. You need to test a system adequately by doing right sort of testing that needs to be done. If you don't do the testing properly, certain things can happen. There are different consequences. Loss of life. A car without a brake definitely will lead to an accident, definitely will lead to loss of life. Loss of business reputation. Will I go back to that same car factory to buy a car, or any of my family member, or will I refer a friend? No, that's loss of business reputation. Loss of money. You have to compensate that family in as much as money can buy life, but you need to compensate them. That same company. Of course, loss of time. So every effort to get that car was just wasted. So those are some of the consequences that you need. Now, the way you test application A is different from the way you test B. For instance, the way you will test a medical application is going to be different from the way you're going to test a normal online application that is just for you to go in and search, nothing is involved. The way you would test an application, an e-commerce application, where you're going to make some payments, things are going to go in, money is involved. Is different from the way you're going to test just a normal application that nothing is involved. It's just for you to look at it and do sightseeing, you are not paying. So these are the way you weigh when it comes to you testing. That's the way you set your priority. You set your goals when you are testing. So there are things that needs to be done. So now we are going to the next phase, which in this phase is I'm going to talk about sorry, just one more. I'm just trying to, please, if you have any question, can you pop it in the chat, please? Any question, please? If you have any question, please pop it in the chat, please. Any question, please pop it in the chat. Any question? Any questions so far? Please pop it in the chat. Okay. Any question? So now, the next one we are going to talk about is error, defect, failure. These are three brothers. They work together. The first one will lead to the second one, will lead to the third one. Error, defect, failure. What is an error? Error is human mistake. It's a mistake. It leads to defects, which cause an observed failure. Error is human mistake. It can be at different levels. It could either be caused by the requirements that you have gotten. It can be in the code that was deployed. And it can be any form. It can even be you that you're tired while you are testing, could cause the error. So I'll give an example. As I've said, we've got a team. We all work together as part of the team. We've got the business analysts, developers, solution architects, testers. So now, the brain behind the whole project will be if you've got a product owner and also a business analyst. They've got a good understanding of the expectation of the users. And once they give that understanding, they come back to the team and relate the same understanding to us. Now, if he or she, the analyst or the product, they don't have maybe there's a mistake or something, there was no clear view on a particular requirement, and they relate it to us, to the developer. What the developer understands is what is going to build. Hence, what I understand as a tester is what I'm going to test. So that issue can be from that business analyst. And once the requirement is faulty, believe you me, the whole application, the whole system, the whole program is actually faulty. So if that foundation, the main requirement, the main understanding is faulty, then if the solution or the design is faulty, then practically whatever we are doing, we are just testing, we are just doing it out of the box. So these are the structure that can come. It can actually happen to any that could cause the mistake. So what you should have at the back of your mind is error is human mistake. It could be anybody within the team. Take it. Examples of error. That's why I said a business analyst may interpret or misunderstand the requirement. Customers might not give insufficient or incorrect. They might provide insufficient or incorrect information. It could be solution architect flaw. It could be people within the team, maybe due to tight deadlines and things like that. Then the second thing is defect. 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 So is an inconsistency between expected and actual results. Expected, actual, expected, actual. All through your testing career, these two words you will always hear the word. You will always work with this word. Expected, actual. What is expected? Expected. I'm writing it. I'm writing my test cases now. I've been given a requirement from the business analyst to do a login scenario. The login functionality in the requirement, it says that I should be able to log in when I use my username and my username, my user ID, and also the password. That's it. An example of that scenario. My expected is that in my script, I'll say, I'm going to enter the username with Yemi, and the password is 123. That's the happy part. That's my expectation from what the business analyst has given to me. Now, what is actual? Actual is now the developer has finished developing. It now gives us the application to test. I now want to test my expected on that application. When I am looking at that application, anything I'm getting there is my actual result. Actual is that currently, this is the application. This is what I am saying. This is what I am looking at. This is what I am testing. So if I'm testing the user ID Yemi, actually I've typed in Yemi into the normal application, the normal system, the physical application I'm saying, and I've put the password too. The same thing. That result that I get, if it passes or fails, is what is my actual result. So what is a defect? A defect in a software product reflects the inability of the software to comply with the specified requirements. Specified requirements. You can see I've been talking about requirements. So if it doesn't comply with that requirement, then it will prevent the software application from performing the expected work. So when you want to, a defect is when I've said username Yemi, password 123. When I get to the actual system, I've put username Yemi, password 123, and it says incorrect after I know I've logged in, or the application crashes, or I'm unable to access it, then I raise an alarm to say this application is not working as expected. I take my screenshot, I write my step to reproduce it, I push it forward to the right channel. That is what prevents it, which means you have found a defect. Now, an error that the tester finds is known as a defect. Defect has different names. This guy called defect, he has different names. You can call it a fault, you can call it a bug. But faults, when some people use faults, it's all these people that have been doing it. But nowadays we use Bug, you roll with the time. Defect. So this guy defect, you can call him a defect, you can call him a bug, you can call him a fault. He has like 3, 5 names like that. So you can call him any one of them if you choose to call him. So you can call him that name. So what is failure? Failure. Failure is a consequence of a defect. So now we have found an error. It leads to a defect. Now the defect is what is failure. So hence you say that application, that software is not working as expected. It's failed. We can't progress. This can be caused by maybe incorrect behavior of the system. It could be maybe an environment failure. It could just be anything that could cause it. It could be the code and everything. So I've mentioned 3 things: error, defect, failure. So remember these 3 brothers when I ask you the question. So keeping software under control. Have any question popped up? Please, if you have any question, just put it in the chat. Any question, please put it in the chat. Okay. So I'll just pause a bit. So someone asked this question. He said, is it a must for a tester who majors in automation testing to have full the knowledge of manual testing? If yes, how does this work? How does the two work hand in hand? Good question. So, as I've said initially, an automation tester and manual testing. Let's just take a good one. I know most of us we don't know how to build a house, but I'm going to just use that as it's just for you to get to a particular land. Our understanding about building is that you must lay a foundation. If you don't lay the foundation and you just build a house on it, no concrete, believe you me, maybe just rain or wind will blow down the house and it will crack. Now take it into testing. We've got the foundation that needs to be laid. Then automation comes on top of it. Now, you cannot do 100% automation. You will do manual and automation. Now, when you are looking for a job, they'll tell you what is the split between automation and manual that you are doing. It could be to the favor of automation. You can be doing a 60 or 70-30. That's 70 to automation, 30 to manual. Now, you have asked that, how can automation testing, before you want to do automation testing, can I ask that if you are given an application to automate, do you just go there to automate the application straight on without having a full understanding of the application? No. Let's just take it a brief one. You want to automate a Google application. They give you the URL. The first thing you want to do is to ensure that, yes, you go into the place, just see, is this a stable environment? If yes, then I can automate. If it's not stable, there's no point where automating it is waste of time. What you have done practically is that you have done a manual testing, a manual check of it to ensure that, yes, this is working. You have looked at it that, yes, this is a stable environment for me to automate. Before you can start automation, you need a conducive place, something that is actually is working, has been certified that, yes, it's a stable environment. Things are already done. There are specific things that have already been progressed. Then you can now automate. Now you ask the question that, if yes, how does this two work hand in hand? The first thing is, you've got your test prep. You don't need to, if you are going to automate, if the organization wants 80% automation, you could just write an high-level manual script for what you are just going to validate manually. And also the automation, you start building on your framework. But the first thing to do you have a stable environment? You ensure that, yes, you have a good understanding. You've done your exploratory testing. You have ensured that, yes, this application, I have a clear view of what I want to do in this application. Then you can proceed to do the automation. They both work hand in hand, to be honest. One is like for one. So you have to do the both of them together. That's the way it is. For testing, you must do both of them together. If you know manual testing vigorously, then I can tell you automation testing will be a playboy for you. So that's the way the thing will work. What is the meaning of stable environment to do? Okay, so what I mean is, if I tell you that I want to do an application, is a green field. We are starting from scratch. Nothing is there. Nobody have an understanding. We're all coming together as a team to start the project. So now, do you want to tell me that immediately you get there, you have laid your framework, you have done everything? What exactly do you want to automate? What do you understand that you want to automate? That is the first thing. So what I mean in my stable environment is, have you gotten the application? Do you have your endpoints? Do you have your URL? Are you able to launch? Has developments commenced? Have they finished? What are the phases? So this is what I mean by you having a stable environment. A stable environment that I have a clear understanding of what we're actually doing. I've tested this. I've done an exploratory testing. Oh, this is what we want to do. This is our main aim. That is what I mean about that. Please let your questions be coming. So the next thing, keeping software under control. This just for the exhaustive testing of complex system is not possible. So we can't say we want to test this system. If you test it from beginning to the end, oh, it's bug free. No, it's impossible. So, and you can't say you would test the whole of this complex system. When I mean a complex system, there are some applications that are very complex. I'm working on an application that is very, very complex. They won't even let the developers go to the database. So I, as a tester, am a mediator between both that application and the developers. If I give them a yes, they will start developing. If I say no to these guys, they go back and do their homework, come back with another file and let me validate that file before I send it over. So is a very complex system. By the time we looked at it, it wasn't something we want to add as part of the project. It's going to affect our timelines. It's going to affect testing. It's going to affect development. Quite a lot of issues. There were a lot of risk raised in the log. So it's a complex system. Now, the first thing I did as a tester, and as you as a tester, when you have a complex system, you need to learn to prioritize. What does it mean to prioritize? You want to prioritize which ones are the risk area first. You go back to the next phase and you go back to the cosmetics. So now what I mean is that the risk area, what is going to cause loss of business reputation, loss of money, loss of life, those areas has to be tested vigorously. Then after that area is tested, you go to the next phase, finances, everything, you go. Then cosmetics, oh, I don't like this color blue. We can leave those ones. It can come back. We can do that later. The major thing is for the application to work and to ensure that there is no issue with the application? Nothing. I'll give you an example. If you are asked to test a car, to drive or test the car, the first thing you want to test vigorously. Can someone just pop it on the chat? What do you think is the first thing that you want to test vigorously? Just put answers on the chat. Let me see, please. You have bought a car. You want to test. You have been given a car to test. What do you think are the first things that you feel fantastic? Thank you, Jolly. Brakes, brake engine. Thank you. Yeah, brake. Fantastic. Me, you are. That's it. We are all, yes, the engine. Adebola, yes, this is what we actually want to test to ensure that, yes, tires, fantastic. These are major things that we need to test. You've all said it. So that's our priority. That will be our first phase. We'll test the engine, we'll test the brakes, we'll test the tires, we'll make sure that everything is durable. We can use that. Then maybe the color of the car. We can sort the color out later. We can sort that one out later. Yeah, that's fine. Just let's go. That can be, if you have time, we'll do the color. If you have time, we will change the roofing. If you have to do, these ones are minor things. That's why exhaustive testing of complex system is not possible. So the first thing to kill this is to run the ones that are of high risk first. Prioritize. When you prioritize your testing, when you're writing your test script, you prioritize them and you put that one. Then, is it possible to run every possible test? Simple or complex? It is not possible. I can tell you that you can't beat your chest to say this bottle of water or this page, there is no error in it. I can beat my chest to say, no, you can't. Because if, for example, you are given you are uh, given a book to read, and you've gone through that book severally, oh, debug it, check for spelling errors, check the contents and the like. You have done it. Maybe your first brief of it, you had like maybe 30 bugs straight on like that. The next one too, you tried, you've gone through, you add another 10. Maybe the next one, another round, another cycle that you're going through again. That's your third cycle. You found another 5. Maybe your fourth cycle, you found one. Fifth one, you didn't find anything. Sixth one, you didn't find anything. Oh, I can tell you that is not what. I'm telling you, give me that book, that same book. When I do my own first cycle, I can tell you I can find another 20. Because the more you read that book, the more you feel you know it, and your faith will skip a lot of things. So that's why you always need a third eye to actually look through whatever you're doing. That's why if you look, when you're doing automation, we also advocate for peer review, someone else to just peer review, go through. Even developers, they do the same thing just for them to see. So those are the things that you can talk about that. When is testing enough? Now we have been talking since. So when do you want to know that testing is enough? I'll take these two words to know: testing and risk. I've said it initially. When you're testing, be looking for the risk. Testing, looking for the risk. The second thing you need to do, testing and quality. As you're testing, be checking the quality. Do we have good quality? Can I say that a user can use this? Always remember, you as a tester, you represent the user. You are representing the public. You are representing the people that are going to use the application. So the way you are going to, the passion you have for that application, you should be able to give it all your best to make sure that you've got good quality. Because when you test, let me tell you, the beauty of it is that when you test, you are the one that have your signature to sign off testing, to sign off the application. If you don't sign off that application, then that is out of it. This phase is a phase that I'm always very, very, when I'm working, they at my place, they know I'm particular about the outcome. The fear everybody, the last day I'm going to send out my closure report, every manager is always on board. I might just be the only one. Everybody will be on board because the question they want to ask me, Yemi, do you want to sign this off? When I say no, then that is no. I'll have to give them a reason. And my reason is always stated in my closure report. My reasons are, I would have written that in my strategy to tell you that what will make me sign off an application is when I don't have a SEV one, that's a severity one, and two, bugs. Those are critical and high bugs, critical major bugs. If they are fixed, now I've tested within 2 hours, I've raised 30 bugs. I just told them I can't continue. Go and fix it. It's not a system for me. 2 hours, I've raised 30 bugs. So you will know that the quality of that application is not, we've not even started development. That's the way I told them. I told them, we've not started development. People will raise eyes. Of course, developers are not happy when you find bugs. But you as a tester, what is your job? You are the one to sign off. But when you now tell them that I don't want to sign off due to all this, and they are happy for them to, then I'll tell them, okay, fine. If you're happy, that's my closure report. I didn't sign off, but who is going to sign off? A project manager can sign off, or the UAT that wants to take it from me can sign off. If they sign off, if tomorrow we are going through the process, oh, SITS did not sign off. Who took ownership of this? Now, my name is out of it. The person that takes ownership, that I signed that off, will have to explain today. So if you know what you're doing, you have to have a clear understanding of what you're doing. Testing and the risk, testing and quality, then that's when you will decide when enough is enough. What are the general principles of testing? We've got 7 of them. General principles of testing. So the 7 of them are: 1, testing shows the presence of bug. Do you agree with me with what we have been saying? Testing shows the presence of bug. All the things you have been saying. Exhaustive testing is impossible. I've just said it now. Exhaustive testing is impossible because you can't just test complexly. Early testing. When you start early testing, that's a fantastic one. You start getting bugs. These are the principles. Defect clustering, pesticide paradox. You keep repeating, retesting, reading through the context. You miss a lot of things. Then after then, testing is context dependent. Before you can test, you need to put something in. Let's take, for example, I want to write with a pen. Before I can test the pen must have an ink inside. So it's the context. You have to put something. You have to enter something to be able to test. You have to wait. Absence of error fallacy. You can't say there is no error. It's a fallacy. Fundamental test process. Now, I'm now going to take this as a building structure. Fundamental test process. These are the processes. These are the things that are needed when you want to test. There are 5. The general principles are 7. Have it at the back of your mind. Fundamental test processes are 5. And they are always two words, which we are going to be, I'll be explaining them. Test, planning, and control. So now we want to start a building. Before you want to build a house, if you go to an architect, we first need to plan. On this land, is 4-bedroom house going to be fine on this land? Oh yeah, they need to know. Then there's a planning session, draw the plan, then the control. Now take it to testing. We want to start a project. We also need to do our tests, prep. We'll start with the test planning. I'll start writing my test plan, doing the strategy, what are the resources, all these. How are we going to control? How are we going to do that? This is the first phase when it comes to testing. Now take the next phase, test analysis and design. Take it to the testing structure now. In the app, you have done your test planning, your strategy. Now you want to analyze. How are we going to start it? What are we going to do? In my expected result, do I have the requirement? Have I done static testing? Do I have a good understanding of it? Yes. Do I understand the design? Yes. Do I have the understanding analysis? Yes. That is it. Now take the third person. This third pair, these two are test implementation and execution, a great phase. This is the main phase, is a great phase here. Test implementation, that's when your test case design start coming in. Now, implementation, I'll start writing my test conditions, my test cases. I'll start writing my expected and actually my expected results. That's the implementation. So I'll form my expected result. Now, after then, I want to start implementing. They've given me the application. I want to start filling in my actual results now that I'm using the application. So I'll start doing the implementation. I'll be doing the execution. But before I forget, in this phase, when you are doing the implementation and before we move down to number 4, in testing, when you are told to write a test cases, and you've written maybe like, let's say for instance, 10 test cases. In that 10, when you are executing your 10 test cases, say for instance, you've executed 6 of them passed and 4 of them failed. In testing, it's not professional to say when maybe as a lead I get there, oh, Yami, how many tests have you, how is it going? Oh, I've executed 60, Tony, just a 60% of the test passed. So 60%, he does the math. Oh, 60%, that's not good enough. If it's 40% that passed, because 6 of them passed. So we do them in percentage, nothing. So let's say 8 of them passed. I can say 80% of them passed and 80% of them passed. If you tell the question I will ask you when you tell me 80% of them passed, the 20, what happened? Is it critical or an eye bug, a major bug? What are your takes on that? So you should have the analysis also to know what it is. So what I want you to bear in mind is that never say, I've written 100 test cases. No, you can give it, you've written 100 test cases, fine. You can say it, oh, I've got like 100 test cases. But when the execution comes in, how is it going with execution? Oh, 60% of them have been executed, 40 of them passed, 20 failed, 40 not run. That is the analysis you should give. Or 20 blocked, whatever you find. There are different tools to be able to get that. So have it at the back of your mind. Never say the number when you are giving analysis of when you are giving or reporting analysis. Then number 4 is the evaluating exits criteria and reporting. Now, before I move forward, another word. Remember, I gave you a word initially. I said expected and actual results. Expected results, actual results. There are 2 guys. They follow themselves. One is for one. If you are doing expected, you are expecting to see an actual. I told you, is good or bad? Good or bad? Now, evaluating exit criteria. This word, I'm going to take another 2 pair of word. So, of the words, that's exit criteria and entry criteria. Exit, we all know the exit door. Exit, stop, go out. Stop, that's it. Entry, come inside, I want to start. So in testing, what exit means is stop. Entry means start. So have it when you go for an interview, when you're asked, what is the difference between exit and entry criteria? Entry criteria is the start of your testing, is when you want to start. Exit is when you have stopped testing, when you want to stop testing. That is when this part comes to play. When testing is enough, this is when that part comes to play. So remember, exit criteria and entry criteria. I'm going to ask you that question. Evaluating exit criteria and reporting. So exit criteria, when I mean evaluating, I told you, I said, I will always write a report. I do a daily report when I'm doing my cycle of testing. I always like to take everybody I like to do transparent testing. I give you a daily report. These are the things I've executed. These are the bugs that have been raised. These templates. Before testing commences at all, I always lay a bed for myself, because in terms of test prep, you are laying that bed. You're ensuring you've got a script. You've ensured your test plan and strategy are signed off. Your scripts are being reviewed by anybody within the team. We are all on the same page. I've got my template for my daily report, and I've got my template for my closure report. All the things I want to put in it are there. It gives you, because you are all going to be under pressure at a certain time, and you need to deliver. Evaluating exit criteria and reporting. So when I say I've stopped testing for today, I need to send the reports to actually back my testing for that day. So I've executed this. So I'll give them the percentage I've executed. I'll tell them this is it, and these are the bugs I've raised. I'll put a mitigation plan. It depends on how I like to put mitigation plans and things like that. Of course, these things come with experience, but of course, some places have where you can just, you have templates. If you don't have, there are 1,001 templates online that you can get. So I build my template myself, and I do things, just a clear picture, because I find out that people want to see picture. You don't write the whole story there. They want to see the graph. They want to see the percentage. They want to know how it's going. And they are not interested in whatever you are. Once it's more than 4 or 5 pages, they don't care again. So your first page should give you a narrative of everything you are going to say in the other slides. So those are it. So then the final one is test closure activity. What does this mean? That's why I said a closure report. Now, Yemi has finished testing. What is the next phase? The next phase is, can we sign off? Oh, yes, XYZ has been done. 90% of them have been tested. These are the issues these are the things. I feel the system is working as expected with whatever. Just put a brief summary and close off the report. Now, don't forget 2 things. General testing principles, 7 of them. Fundamental test process, 5 of them. So this is psychology of testing, just mainly wrapping up to tell you this is testing is done by different phases of people. We are talking about both the developers, testers, everyone can be called into testing. So that's it. But before I continue, I'd like to ask question, and I know, because my class people they've been following. Okay, let me just, before I answer the questions, so let me ask my own questions. Before I answer the question, I will ask my question. The first question I want to ask is that, how can testing be done? If you know the answer, please just pop it on the chat. How can testing be done? Remember, there are two ways testing can be done. Who is helping me out? I've not. Thank you so much. Thank you. There's one ORG Blue. Yeah, thank you. Adebola, thank you. Taiwo. Yeah, fantastic. Oh, I've got fantastic people here. Felicia, yeah, I can see. Wilfred, Dami, yeah, you all got it. You all got it. So I owe you. So I'm going to give you one stick each. Please help me just count. So those are the ones I'm going to give them. If you've answered, okay, Olusegun Yaku, yeah, manually and automation, yeah. So the next thing is, okay, I'll get them now. Okay, good. Yeah. So now the next one is, what is error? First to type, we'll take two suites now. First to type. First, I'm waiting. Fantastic. I think who got it? You both. Yeah. No. You see now, we are mixing it up. Human error. Oh, it's not bug. I asked for error. Error now is human mistake. Now tell me, what is defect? Defect. Thank you, Felicia. Yes. Afisat, yes. Yes, it's bug. No, you can't tell me that error is bug. Correct. Thank you, Kayode. I mean, Lydia something, I think so. Lydia, yeah. E, yeah. Because you can't tell me it's a bug. I know it's a bug. I told you that defect guy has three names. He has several names. Is a defect, is a bug, is a fault. So now, what I'm expecting you to tell me, the meaning of defect is the inconsistency, the inability, yeah. The different, yeah, thank you so much, Moyiwa. Then the last one, what is failure? First to type, let me see, failure. I've got fantastic students in this class. Failure, you have not seen your name. The suite is going, no. Is going. No work, inconsistent, yeah. Non-functional. No, this is still, you're still typing defect, inconsistency between actual and expected result. Correct. That's for defect, absolutely. Taiwo, thank you so much. Consequences of a defect. Fantastic, Busola. Thank you so much. Yeah. Happy. I'm happy that yes, you all understand. So let's go for another one for how many general principle steps do we have? How many general principles do we have? Fantastic, Busola. Thank you. Oh, these are good. Now, fundamental test process. No, it's not 5. The person that said 5. No, it's not 5. Yeah, 5 now. Yeah, 5. Correct. Fundamental test process. 5. Yes. Well done. Clap for yourselves. Yes. So I'm going to distribute all this. So don't worry. Via the post, just be waiting for it. Yeah. So now we'll continue to the next stage of that. Okay. No, before I continue, let me just go to the question. Thank you for sharing the suite. Thank you. Please just let me put the image of the suite there. Please, thank you. Okay, someone asked here that, I think the question was from Ajibri, said test script and test cases. Good question. I suppose the test cases are different. No. So let me go from here before I answer the test script. What? I want to make sure I've not missed any. Okay. So someone is asking me what is the difference between QA, test analyst? That's what I explained to you. I said is a role, it's just a name title. Everybody just put their name. And what is IR35, inside or outside. This ones, I think, is a different ball game. Is when you're going for contracting and you can answer IR35 is a new regulation rule that's been in play for like almost going to 5 years now. So if you're inside, then if you are getting particular money is going to be half. You have to check with your accountant. If you're outside, then you're getting your full pay. So that's the difference between it. But for you to know, test and software engineer, they are all part of software. Then I think someone asks test script and test case. What is the difference? So test script and test case. We are going to get there, but I'll just give you a brief knowledge of it. Test case is you when I've explained to you previously when we're doing the fundamental principles, when you're doing the implementation phase, you have written your test condition, you put in your test steps, you have put in the expected results. That is the implementation phase. Now, when you execute it and you started writing the results to you under your actual, is the login scenario pass? What is the status? Is passed. If it fail, fine. When you collate all those analyses, that is a script because you have executed it. But test cases is mainly a focus of you putting all your script with expected results. You have not actually executed the test. So that is it. I think those are the things that I have currently. Someone is asking that who gets something like the report? Who do you give this daily report to? So look, these reports are shared within it depends on your stakeholders, the people you're working with. We do it within the team. I ensure that everyone within the team, the development team, the analyst, the project manager, every one of us that are involved in that thing are the people I share the results with. And also maybe some other new stakeholders might want to join when it comes to seats. So I share that result. The people that are going to take the decision are the people I shared the result with. So it depends on different organization. So you can, but most of the time, that's the way it works. So as I go back into it, so this is another phase, and I'm going into another topic, which is called learning. The person that asked for test case and test script, to be honest, as a tester, if you understand all this nitty-gritty, all these things I've been talking about since, the major job you are doing is to script, execute, implementation, and execution phase. If you know how to write a script, that is it. You've hit the target. If you know how to write your test plan, and let me tell you, in the internship, these are the things that you get there. These are the things that you are expected. We teach you the basic way. You will get different help with the templates to write your test plan and several test plans. Script, you will design your script yourself and you will keep it. You yourself will still go back to it in the next 10 years. When I still look at some of the scripts I've written like 12, 15 years ago, I'll still be laughing at myself. So you keep building on it. But those scripts, I can tell you that I know everything in all my scripts. So this is the major work. When you mean fully hands-on, if you're listening to me now, you are in the right place. You will enjoy your internship. Full hands-on on automation, full hands-on on a manual, and the manual, you're going to use tools for all these things. And if you know one tool, you can use all the defect management tool. Take it from me. Okay, so the next one is learning objective. So the learning objective for this time, the next phase is that I've finished this particular chapter, I'm moving to another one. So is software development life cycle. Don't worry, I'm going to give you like 5 minutes at the end of the class. We'll just, if you need to say anything, you or ask question, I'll just give it. So software development life cycle. That's one thing. I mean, different models of the software development life cycle, the pros and cons, that's the advantages and disadvantages, concept of understanding. That's the next phase. So now, software development life cycle. As I've told you initially, I told you when I was talking about the life cycle, everybody, we've got different phase. I started, of course, when you are in the womb, you've gone to, you are now 5 years, you are 10 years, you are 50, you are 60. So that's the way life, 80, 100, that's the way is the life cycle. Now, take it again. Take all this, when a chicken lays an egg, the first thing is that you lay the egg. In that egg, the egg will hatch. We've got the chick that will come out. From there, it grows to little. That's the way. So now, we too, we want to do the same process in testing. So we are now going to talk about software development life cycle. In a short form, is SDLC. So anytime you see SDLC, is software development life cycle. Anywhere you see it, software development life cycle. Now we've got different life cycles that we go through. One of them is waterfall, V model. We've got rational unified process. We've got spiral. We've got V model. We've got Scrum. We've got Kanban. These are different ones, but the major ones that are well known that we use now, the major SDLC models are waterfall, that's the linear model, V model, that's the sequential developmental development model. We've got the iterative incremental development model, which is the agile. This is the selling guide now. Agile, you must know it. And it's quite easy. You know, this thing is just name. When you are there, because when you're in the internship, you are working as if no, you are in the field. It's a live project, so you're working in the field. So whatever you learn in the internship, know it is your work experience. Take it, is your work experience. So now, I'm taking the first person, which is waterfall. Just look at this diagram, this beautiful thing here. If you look at the way it's going like a waterfall. That's the reason that it's called waterfall. Now, the concept behind this waterfall is one. If you look at it, requirements, design, development, testing, deployment, in maintenance. Now, in waterfall, this is how it goes. They'll do, if the business analyst, until she finishes the requirements, we can't do anything. We all have to wait. When she finishes the requirements, she sends it to the design. The design guy finishes his own. He sends it to development. Development finishes his own. He sends it to testing. Testing does the same thing. He sent it to testing, we send it to deployment. Deployment, then maintenance will go to them. Now, the problem here is if there is a mistake in the requirement, it's pushed to the design, it's pushed to development. Now, when it gets to testing, if it breaks, we can't do anything. We have to follow this process. We're now going to start from the beginning again. Do you know what it means? It means that all this time, we've wasted time and resources. Then we're starting all over again. So we go through this reiterative again, go back, go back, go back. If there's an issue when it's testing, you go back again and start. If it's maintenance, you start from all over. So it is the advantage here is good if it's a small project that we all understand it. Everybody knows what it's all about. It's a little project and you all understand it. Then you can say that, yes, you can use this model. But if it's a big or a complex project, it won't work because one is going to be more of a setback. Everything will still to the later stage. There is very expensive. Don't forget the person, all these people, every one of us here, we are resources and they are paying us. So if they're paying us and there's time that you are wasting, you have to go back again. Money is well so is going to be spent. So all these things are put into consideration when it comes to software to waterfall. Now I'll go to V model. If you look at the shape, it's a V shape. It's a V shape. So in this one, every phase has a testing phase attached to it. So if you do the user requirement, you do acceptance testing attached to it. If you do the software application, there's a system testing attached to it. If you do high-level design, there's integration testing attached to it. If you do a detailed design, there's unit testing attached to it. Now, take another two words that I'm going to tell you. This one, I'm certain is always asked most of the time in the interview, and is always people are getting confused. Verification and validation. Remember, the first one I gave you was expected and actual result. I'm giving you all these twins for you to understand that these twins, they work hand in hand. The questions are asked hand in hand. Expected and actual result. That's the one I gave you initially. I gave you exit and entry criteria. That's two. Then the third one now is verification and validation. Verification, validation, to verify, to validate. Verify means, are we doing the right thing? That is what you want to verify. Are we doing the right thing? You are asking a question. That is what you are looking for. That's verification. So verification means, are you building the right product? Validation, are we building the right product? That's one question. Does it meet the user's need as intended? So does it follow what is now validation? Is that, does it follow what is in the business requirement? Does it follow what the business analysts have given it to you? Is it what the users want? Is that the mind of the user? That is it. So remember, verification. Are you building the right product? That's the first question. Validation. I'm still asking that question in validation. Are you building the right one? Does that product that you are building, does it meet the user expectation? Do you understand what I'm? So this is the third tool now that I'm giving you. So these are explanation of each of the phases. Verification phase and validation test phase. So what happens in the business requirement is that you've got a detail in the business/user requirement, you've got a detailed requirement. The acceptance testing is that this involves the product in the user environment. So we take the product to the user environment, ensure that yes, they've got a good understanding of what we want to do. Then software application design. How will this system work and interact? So how is it going to interact? So we take this one, we do a system testing check for the validation phase. We check the entire system functionality. Third level, we do the architectural/high level design. So these are you doing mainly a technical detail of the project. What are the components? What are how is the structure of the system? Then we need an integration phase. This is mainly how do they come together? How does everything marry up together? You have done a component of login separately. You have done search separately. You have done add to cart separately. You need to integrate them together from login to search to add cart to do this. That is that design. Then we've got the module/detailed design. This is more of a unit testing. phase. So unit testing is acquired and put it into that phase. So the last bit of this is the agile. This is the interesting one. So in agile is more of an incremental, more of an iterative way of working, an interesting, easy way of working. So in this, maybe like incremental phase, just for us to understand it. So at this, the agile phase, first thing is that you start with maybe one, a login application. That's what you want to do first. We'll do the login application, we'll test it, ensure everything is fine. We are not doing anything aside from login in that sprint. That functionality is working as expected. All bugs have been captured. The code is being stored. It's fine. So, which means we start first. We get the requirement for the business analyst gets the requirement for the login. So these are all the phases that we want to do for the login. Both the negative scenario, the positive scenario, anything that's got to do with the login. That's what we were going to handle in that sprint. When we finish, we take it to the design. From the design guy will build only for login. The developer will code for only login. The tester will test only login, just for me to be able to log in. Then we'll send the product to the user. They'll do the so we'll finish one. The next phase we want to do is that we want to be able to, maybe we want to see the landing page. Another one, we add the landing page. Get requirement for only landing page. Business analyst gets the requirement for landing page, put it in design, coding, testing. We put it to the user. Are you happy, user? Yes, we're happy. We peg that again. We put it there. We keep it somewhere. Now we take another thing. We want to do the search functionality. Now we go coding for login, landing page, search functionality. We keep that one again. That's the way Agile is. We test in bits. We test very early. We start everything early. What is the pros for this? Quick delivery to market. Customer can provide feedback to each product increment, thus avoiding surprises at the end of development. Requirement changes can be easily accommodated. What is the disadvantage? Requires effective planning of iterations. So that's where we are going to next. So what I've done, the explanation I've given to you with my mouth is just requirement, analysis, design, coding. That's first iteration. Second iteration, I go again, requirement, coding to until you get to the end. That's the way we keep doing it. So now, this is iterative incremental development model, and the agile way start first. Definition of ready. Are we ready? Do everybody understand what we are starting with? Yes, this is we want to do project Hear Me. In this project, this is what we want. We've taken everybody with the resources that we are going to need. We are all gathered, more of a kickoff to start. We put everything, all the requirements, go to the backlog. Backlog guy, he will store everything for us. He will keep it for us to have a good understanding that anytime we back to you. So everything we want to do, we will be dumping it in the blog. Everything that have been asked from the user, that the user wants for that application to be done, will be stored in the backlog. So from there, we'll start our first sprint. We start first with a sprint 0. That's more of a skeletal sprint. Just let everybody have a good understanding. Okay, you that you need a test environment, you that you need this. So everybody is getting their shape into the project. Now, the next thing is sprint 1. We all start. Take the first sprint. The development has started. From sprint, it goes to the development, does its development of the login page. From there, once it does finish doing the login development, it sends it to the tester. Tester test, we send it to integration. Integration does their own testing. From it goes down to delivery. Delivery definition of done. That phase is done. So go back to this guy again, to backlog. From the backlog, we pick another one for sprint 2. And always remember, each sprint, most for Agile, is meant to be fortnightly. That's 2 weekly. But in some organizations, they do it 3 weekly, they do it 4 weekly. Not everybody practices Agile in full, but have a good understanding of it. It's very easy. So that's it. So you just go through the loop like that. From here, go down to definition of done. That's it. So the same thing I've shown. Requirement, design and development testing. That's build 1. You go again, build, design and development, implementation. You go to sprint to third one. You do, that's the way you do until you finish the iteration. All this will be explained properly. So now, I got my pen for the class today, and I open the floor for anyone that's got any question. Let me go to the question. If there are any questions available there. If any question, please pop it into the chat. Okay, wait, so the software development life cycle. Okay, sorry, maybe someone help me to answer the question. Knowledge of software design. Do you need to be very good in IT to have knowledge softwares before you can? Let me tell you, people that don't even know IT, I've seen them get fantastic roles in this internship. I can mention a lot of them. They've got no background in IT, no background with computer, nothing. They don't have anything, and they're able to. You don't need to have any background. That is why this foundation, we are laying it. Everybody is hands-on to. The only thing required of you is your dedication, your time. Just take it that my 3 months, my 4 months is for me to know the knowable. I'm telling you, testing would just be like bread and butter for you. And it just takes one role for you to go. Just one. And I tell you, we've got people that are going to tutor you when you have any interview. With the interview prep, you are certain to have a good interview. I'm telling with my experience with the team, maybe by the time you go for 1 or 2 interviews, you'll be getting several job offers. So don't limit yourself with, no, you don't need to have these things I'm telling you. what I'm teaching you now are things that you need to know. That's what I'm saying, their foundation. So let me go again. Let me go for the one. How often do you use templates in both manual and automation testing? It depends. It depends on how you want to put your like I like me. I know people most of the time. Not a lot of people want to read things, so they like pictorial things for you to give them a good picture and give them a good analysis with that. So a quick pie chart, a quick bar chart to just say 80% of this XYZ have been covered, blah, 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 and go for that. Which is better for new entrants in IT between career in BA and testing? I, I don't want, I can't be biased now, but to be honest, I find myself in a shoe where I'm a test analyst. My husband is a business analyst. Now, ask me, he's very good at talking, very good at talking. But me, I love to get my hands so dirty. Even the way even with a lead role, I always get my hands. I like to work. That's me. So anyone, it could be a BA. So it's you now. You need to know yourself. What do you like? You have gone for the BA class. You have come for the testing class. What do you like? Can you manage stakeholders? Can you talk properly? If you can, then your choice will be a business analyst. If you love to do more technical things, then you'll be a tester. If you're good at bringing people together, then why go for a project manager? So anyone in IT, we've all got our places. So look at your character, look at what you are good at, then fit yourself in the IT world. Can we say verification is asking, are we building the right product in the general principle? Why validation is asking, are we building the right product with respect to customer? Yeah, that's it. So, yes, you're right, absolutely right. So, verification is more of, are you building the right product? So, verification now is, yes, are you building the right product? Have you followed all these principles? Have you gotten? Then validation. Even if you're building the right product, does it meet the customer needs? You might be building the right login when the customer is telling you, don't use user ID, use username. So those are things that you need to clarify. So that's it about it. So any other question aside from the class? Any other question? In the absence of no question, I think we'll need to call it a day today. I thank you all for taking your time. Okay, is there any other question coming in before I finalize? Let me see. Okay, I thank you all for your sweet. Don't worry, I'm sending the sweet. Thank you. Thank you, Prince, for giving me the sweet. Look at the one Prince just sent. He has shown me the sweet. He's a big one, the lolly stick. So thank you all for joining the class today. And hopefully I'll see you again next week. And I wish you all the best. But I can tell you once again, you are in the right place. Don't think twice. This is the right time for you to take a step. I wish you all the best. And we'll speak next week again. And I'll see you at the internship. Have a wonderful evening. Thank you.